Today I'm going to show you how to use the Reese's Pieces applet to model the sampling distribution of sample proportions. As you can see, there's a candy machine full of Reese's Pieces here, and you can set the proportion that are orange in that population, which is usually something we don't know. So you could change it to 60%. I'm going to leave it at 50%. The number of candies that the machine is going to randomly drop out is set to 25. That's your sample size. And we're going to take one sample at a time. Now what happens when you draw your sample, the Reese's are going to come out and we're going to calculate the proportion of candies that are orange. The default is set to the number of orange that come out, but if you just click here, it'll change to the proportion of oranges. Okay. And as you see down here, there's now 32% of our sample came out to be orange. So I can continue to draw samples. This time the proportion of orange is 48%, and then it gets dropped down here into our dot plot. Now you can take one sample at a time. There's that 0.64. Or you can get rid of the animation and take repeated samples. So say for example I wanted to take maybe 5 samples. So I'm going to draw the 5 samples. It's not going to animate it, but the 5 dots do show up down here in the dot plot. Okay. If you wanted to animate, you can. However, it just takes a little bit longer as it's going to take 5 samples in a row. But you can see that the most recent p-hat will keep showing and then being graphed in the dot plot below. So here are the samples coming out now. It is a little bit quicker if you don't animate the drawing and just click the 5 samples. I think it just does the first one for you, and then it'll map, it'll dot plot all 5 of the p-hats. Okay. We can even change the number of samples, let's say to 20, so we can start to see what shape our dot plot becomes. Okay. And you can see over here that the total number of samples is being recorded. Okay. Now remember that the distribution of p-hats will be approximately normal, with the mean centered around p, the true population proportion, and the standard deviation is the square root of pq over n. However, you have to make sure that you meet the certain conditions. The sample must be randomly selected from the population, which is happening because the candies are being randomly drawn from the candy machine. The number of successes and the number of failures has to be greater than or equal to 10. Well, remember that our sample size was 25, and our probability, or our percent of orange, was 50%. So if I multiply those two, that's 12.5%, which is greater than or equal to 10, and that's the same thing for the failures. Okay? That also comes out to be greater than or equal to 10. And the last condition, we have to make sure that our sample is less than 10% of the population, and it seems reasonable to assume that the 25 candy coming out is less than 10% of all the candies in that machine. Okay? Now, because we meet those conditions, we know that the distribution of p-hats here will be approximately normal, and the mean will be centered at the true population proportion, which is up here at 50%. If you click the summary stats, you could see that the mean of this distribution does come out to be 0.5. Okay? And if you calculated the standard deviation, it's going to come close to be 0.1 also. And the more samples we take, if I take 20 more samples, the closer the mean will approach 0.5. Now, if you wanted to, you could calculate some probabilities. Maybe you want to see what's the probability that the proportion of orange M&Ms, let's say, is greater than 0.64, and it's going to count them for you and tell you that that probability is about 12%. So that's how you use the Reese's Pieces applet. The link you can see is up here, but it's also on my blog above the screencast.